So now we're going to talk about different shapes that graphs can have. These histograms. Our first is symmetric. It's a distribution is approximately symmetric if the upper and lower halves of the distribution are about the same. So under symmetric, we can have that mound-shaped graph like this one. A distribution is described as mound-shaped if it's approximately symmetric and has a single peak. A normal curve as a specific mound-shaped curve, and any data distribution that makes a mound shape is approximately normal. These distributions occur in many different settings, so we'll be working with that actually in the next lesson. This distribution is approximately symmetric. All the bars are about the same size on both sides, but it is not mound-shaped. Each of the bars is about the same height. So that's talking about that graph versus the mound-shaped graph that's up here. The next two, skewed distributions. A distribution is described as skewed if most of the data is clustered on one side and you kind of have a tail on the other side. So here we would say this one is skewed to the right. So basically wherever the tail is, that's how we say the direction of the skew. So this is skewed to, should I say that here, the left, because it has a tail on the left side. So here we have another histogram. We're going to kind of go through those steps. We see no histogram. We see a frequency table, and we're just drawing a dot plot for this one. So you can quickly do that. I'm going to draw it up here if you want to pause the video. So we have the 11, and we have 2 12s, 2 5 13s, 7 14s, and 6 15s, 5 16s, 3 17s, and 1 18. So we see, it says looking at the dot plot, do you think a normal distribution would be an appropriate model for this distribution? Yes, it's mound shaped, so as we get towards this thing called the normal distribution, we could use it. So yes, it's mound shaped. So now it says find the mean and standard deviation of the number of machine errors per day. This data is about machine errors and then how many days the machine had that number of errors. So we'll go back to our calculator. We're going to go to stat, go over to calc, not to calc, sorry, stat and edit. Now I definitely have data in there from the last question, so I have to press clear enter for both of them. And then I'm going to start to enter the new data in. So this one I have 11, 12, and I'm going through 18. And both of our examples here, we have numbers that go in order. They can skip around too. It doesn't have to necessarily be consecutive integers when we enter them into the table. And then for our frequencies, we have the 1, 2, 5, 7, 6, 3, 6, 5, 3, and 1. So I have all my data and they're even. We're going to go to stat calc. This is explained slower in the previous video, so if you need to go back to that one, you can. One variable stats. Now, if you've already set it up, L1 and L2 will be there. Just make sure you check and make sure they are. So here are my statistics. So going back to the lesson, this one, it says find the mean and standard deviation of the number of machine errors per day. So my mean was 14.6, and my standard deviation was 1.7 to the nearest 10th. So we're going to mark the mean and the values 1 and 2 standard deviations above and below the mean on the dot plot. So the mean, which is 14.6, would go right here. Okay, maybe a little closer to the 14, but doing the best I can with the smart work pens. So that's our mean, 14.6. And then we want to add 1 standard deviation. So the mean plus 1 standard deviation is going to be 14.6 plus 1.7, which is 16.3. I'm also going to subtract it, and that is 12.9. So I'm going to mark those two in green. Kind of wish I wrote it in green. So 16.3 is here. That's plus 1 standard deviation, and a plus 1 actually we'll see just implies 1 standard deviation. And then minus 1, the 12.9. So that's minus 1. Now I could just kind of tack onto there, but it's typical to do mean plus 2 standard deviations, so I could just add the 1.7 again. I'm going to start from the mean and add 2 of them. So that would be 14.6 plus 2 times 1.7. And then in the opposite direction, since this is our first time with this, I'll write it down. The mean minus 2 standard deviations. So that's going to give me the other 2 numbers I'm going to label. So that gives me 18 and 11.2. And all of this is pretty basic math, so you can type it in, but I'm assuming that that part should be good. So that's plus 2 standard deviations. And then the 11.2 is minus 2 standard deviations. Okay, so those are labeled. And now the last question says approximately what % of the data values fall within 2 standard deviations of the mean? So it's a little tricky. I am going to include not the 11, right, because we're cutting it off at 11.2. Okay, so I'm going to move this back up. I'm going to include all of these dots, and this one's kind of cut in half, so I'm going to count that as a half. Okay, so those are all the dots that fall between the -2 and the 2. So really, we have a total of 30 dots. So this frequency is add up to 30. Okay, and I could count them all, but really I'm including all the dots except for the one at 11, and I'm including half of that one that's cut in half. So that's 28.5 out of 30. And that comes out to about 95% of the values. So 95% of the values fall within 1 standard deviation of the